Okay, so just a little review from what we did last week and a half. We talked about three conjectures that make triangles similar. Now, see if you can pause the video for a second and write out what makes triangles similar. Okay, well, let's see if you did it. Number one, AA is a conjecture that makes triangles similar. Number two, side, angle, side is another conjecture that makes two triangles similar. And then the third is side, side, side. Those are the three conjectures that make the triangles similar. Now, what we're going to be talking about today is parallel lines and how they make triangles similar. So what I do on the notes is I give you a triangle and I say this is the very first thing. It says ACB. And then I draw a parallel line and I do this. Let's say this line is parallel to that base. Well, what you might not know right now is if I were to redraw this big triangle right here and this little triangle right here, these two triangles are actually similar. And the reason why they're similar is because, look, in parallel lines, these two angles are corresponding angles, and they're always congruent with parallel lines. If these two lines are parallel right here. Okay, now let's draw another line that goes through it. In this angle and this angle are called corresponding angles, and corresponding angles with parallel lines are always the same. So what you hopefully understand is, like, if I were to get rid of all of these, you actually have this same figure where this right here shows that these two are the same, and this little triangle shows that these two and these two are the same. So what conjecture makes these two triangles similar? The answer is angle, angle. So angle, angle is what makes these two triangles similar, because whenever you have parallel lines, you have corresponding angles here and here and here and here, just like this, that are congruent, so therefore the two triangles are similar. Now, this is the thing about similarity with parallel lines. If you have parallel lines, it's something called the triangle proportionality theorem. What that means is this. Let me redraw this. So here's my two parallel lines. And this only works whenever you have a line that's parallel to the base of a triangle. What the triangle proportionality theorem says, you can set this up as a proportion, but you have to put it in chunks. You would have to say this over this equals this over this. Or this over this equals this over this. Now, what I went ahead and did is I labeled everything A, B, C, D. And then the triangle proportionality theorem says A over B, this over this is equivalent to the exact same proportion as C over D. And another way you can write it is this. You could say A over C equals B over D. Okay, the reason why that's important is because look at the two example questions that I give you. With the two example questions that I give you, I give you a triangle where you have two parallel lines. Now, since you have these two parallel lines, you can assume that these two triangles are similar. And if these two triangles are similar, you can assume that A over B equals C over D. Now, that's important because if you're trying to solve, this is 12, this is 5 in the example with the notes that you should have printed up or should be looking at right now, and this is X and this is 4. So if I were to set up a proportion to solve for X, since this triangle is similar to this triangle, the triangle proportionality theorem works. And I can set this up a couple of different ways. I can say 12 over 5 equals x over 4. And then cross multiply to solve. That's one of the two easiest ways. Another way I could set it up is this. I could say this side over this side, 12 over x equals 5 over 4. And when you cross multiply, see how you're doing still 5 times x equals 48, which is 12 times 4. Another thing you could say is this. Look, I can separate these two triangles. Oh, actually, let's do this. I think the next example is going to make a little more sense. No, I'll go ahead and do this. If I were to redraw these two triangles, here's my big one, here's my small one. I'm going to show you just a couple different ways that you can still set it up to solve for x. This is a little more complex, but I'm just explaining a concept to you. Since these two triangles are similar, this side is 12 on the little dude, but this big side right here is 17 because 12 plus 5 is 17. This side on the little dude is x, and this side is x and that 4. We're just going to call that x plus 4. So I can actually get rid of it, and I can say, look, 12 or 17 over 12 equals x plus 4 over x. Or 17 over x plus 4 equals 12 over x. And you can cross multiply to solve. It's way easier to do it the other way that I showed you over here. But the same concept still works. Okay, the last example that I'm going to give you is what I do is I give you a line that's parallel to the base. This is 9. This whole thing from here to here is 18. So if this is 9, this has to be 9 also. This is 3x, and this right here is what? 20. Okay, so now I'm supposed to solve for x. What I'm going to do is this. I'm going to break this triangle up. I'm going to draw it little. I'm going to draw this dude right here separately. This is 9 and this is 3x. And then I'm going to draw the big one. The side on this one is 18. The side on this is 20. Now, since I redrew them with two different triangles, I can set it up as a super, super simple proportion because these two sides are congruent to these, or these two angles are congruent to these two angles. So therefore, the triangles are similar, and you could say 9 over 3x equals 18 over 20. Or you could say 9 over 18 equals 3x over 20. No matter how you do it, see how you're going 18 times 3x equals 9 times 20 there. Or, look, 18 times 3x equals 9 times 20. See how you can do that? Doesn't matter how you do it. You're still going to get the exact same answer. Okay, so the answers are in, or the notes have your assignment. The answers are attached to this as well.